Hello and welcome everyone. My name is Mark Henry. I'm a senior engineer with opMantic's North American office out of Charlotte, North Carolina. Today we're going to talk about how to create scripted responses inside opEvents EventActions system in order to respond to events that are being processed by either NMIS or from incoming syslog or SNMP trap systems. A few useful references for you. The key one is going to be the opEvents wiki page on opMantic's community. You also have the community questions board. If you have support issues, if you're a supported customer, please email support@opmantic.com or come through opMantic's support portal on opmantic.com. And if you'd like to know more or schedule a demo, please reach out to USA@opmantic.com and one of our sales agents will reach back and schedule a demonstration with you. So a quick background about opEvents. In this example that we have, we're showing a two-tiered deployment. The use of a polling server, which is communicating directly with a group of devices, whether it's a subnet or a LAN or a WAN region, whatever devices it can communicate with. opMantic's core NMIS solution is processing SNMP and WMI, so it's reaching out to those devices and executing commands to collect SNMP and WMI information. It is receiving and processing SNMP traps from those devices, and it's also conducting service monitoring. So it's making sure websites are up and running, that user experience is good, and that SaaS solutions and applications are working appropriately. Events from these devices are being processed by NMIS's escalation system. Now, NMIS has a very basic escalation system that handles events one event at a time. While it does have the ability to do some dependency application, so understanding, for example, that a server is relying on a switch, which is relying on a router, which is relying on a firewall. If the firewall goes down, the dependency system in NMIS can understand and suppress the events below the firewall. It doesn't do this automatically. This has to be manually configured inside NMIS. NMIS also does not do event correlation. So it does not look at multiple events and roll them together into one event, nor does it handle event storms or event flap. So if you're looking to expand beyond NMIS's escalation system, you would end up employing opEvents. opEvents takes the event stream from NMIS and processes that. It also takes syslogs, incoming syslog files, parses those and turn those into actionable events as well. So opEvents handles things like whitelisting and blacklisting. It does event correlation and deduplication. It'll handle event storms, event flaps, and more importantly, it'll do what we call event remediation. In many cases, the event remediation that our users put together, they'll generally follow a crawl, walk, run methodology, where crawling, they'll set up event correlations. They'll also handle emailing events or sending SMS text messages. They may open help desk tickets. The next level, the kind of going from the crawl to the walk concept, they'll look at events and they'll say, how can I automate troubleshooting an issue? Or they'll say, now that I know that I have an event and I know exactly what to do or what steps to take to remediate or fix that event, then they'll put those together as responses inside opEvents EventActions system as well. So that's where we're going to focus on today, is how do I put together those responses, whether they're troubleshooting, gathering information, or whether it's actually reconfiguring devices and networks to work around events that are occurring. So a bit about the processing flow inside opEvents. There's a series of tasks or steps that opEvents takes for every single event that comes in the system. When an event arrives, the first thing that happens is we apply an archive list. So there are rules and commands for how do we store, how do we archive an event, where do we store it. So you could take an incoming event and you might store it into a JSON file. You might echo it out as an SNMP trap out to another system. You might write it out to a syslog file and have that forwarded to another system as well. So a lot of things can be done with the archive list opportunity. The next thing that we do is we apply a blacklist, then a whitelist. We then correlate that event into other outages. The next thing we do is we deduplicate those events. We then determine the event priority, and then we start the event actions. And that is the piece that we're going to talk about today, is that block in red, opEvents, event actions system. So how do we define scripts inside event actions to respond to events? So the first thing to understand is the rules that include the scripts are all contained in a text file. This is a plain text file called EventActions.nmis. This file is compiled into memory, into system memory, every time the opEvents daemon or opEvents D is restarted. So when the opEvents D is restarted, it reads the EventActions.nmis file into memory, compiles the rules that are in there, the scripts that are in there, and ensures that EventActions.nmis is formatted correctly and that everything inside it is executable. So these script sections, you can access them directly at the command line by editing EventActions.nmis with something like Vim or Nano, or simply by going to your opEvents interface and in the menu selecting System, Edit Event Actions. Now I'm going to go ahead and zoom in on my browser, make this a little easier for us to see. You can see here at the top of this file that there are several rules that are happening. This file is actually broken up into sections. The first section is policies. Policies is a series of if-then rules, which simply say, if this is the situation, if this is the type of device, if this is the type of event, if this is the customer, the location, the time of day of the week, day of the month, then do these things. The next section that you'll see here, if we come down past the policy section, you'll see there's a log section. So we're defining different types of log entries. So we're defining a log that we can write out to. We're providing a format for that log. You can see here we have a text file defined. We also have a JSON file defined. We also have a directory that we're writing those logs out to. So we can actually write, we can call these log files, and we can write out to these log files information if we want to. Next, you have a section in the event actions file called scripts. These scripts are just what they sound like. You are providing a path and name of a file to execute. You are also passing it a series of arguments. And in this example, you can see here we're passing it some properties of both the device that's having the event and the device's fully qualified domain name or IP address. And then we're also telling the event action systems whether it should save or expect a return, an output from calling that script. In this example, we're calling a script written in Perl, so it's a .pl file, and we're passing it the node name and the node host. If I scroll down a little bit further, you'll see, for example, we're calling here's a program, nmap. So we're calling nmap, we're passing it a series of arguments, -s uppercase V, and then node.host. So again, the IP or fully qualified domain name. You can also call any kind of a Linux command as well. So in this example, we're calling the df command inside Linux. So we're asking for drive space information. We're passing it the argument -h. So we want the information in human readable format, and we're saving the output of that. So let's take a look at what some of these look like in execution. So I'm going back to the opEvents dashboard now, and I'm just going to scroll down and see if we can't find a good example. So sort by priority. So here's an interface discard output packets event. And if I scroll down, you can see that a troubleshooting escalation was started, and it called the script mtr node. So if I scroll down inside this detail window, You can see the results of that MTR node are down here at the bottom, and the results of the ping node are here at the top. So all of these are stored in reverse order. So for example, the escalation started first, the MTR ran second, the ping node ran third, and they're from bottom to top. The results are also stored bottom to top as well. So the first thing that runs is going to be at the bottom of that script section inside this interface. So switching back over again to the event actions file and zooming back in, let's take a look at how a simple escalation occurs. So here's a good one. We're looking for a specific type of event. We're saying if the event is stateful, contains BGP peer, so QR is a regex command, so it means find something which contains or something like the phrase BGP peer. So if it contains that phrase, then respond with this whole series of steps. So it's immediately going to execute. It's going to change the priority to a priority 8. It's going to execute the script ping node. So notice the format here. It's saying script dot ping node. So it's calling a script, and this is the name of the script, ping node, and open and close brackets. Then it's going to call the script ping neighbor, and it's going to call the script troubleshoot BGP. The last line here, break equals false, means when it completes this sequence of events here within this this block titled 110, once it completes the sequence of events, it will continue down through the file, continuing to evaluate other rules to see if any other rules also match this event. So multiple rule sets can match against a single event. So let's take a quick look here at what the script ping node looks like. So we're going to scroll down to the ping section, or rather to the script section, excuse me. And here's our ping node. So here we're showing the full path to the file, so /bin/ping. We're passing it the arguments -c5 and also node.host. And then we're going to save the output of that file, or of that script. Notice in the ping neighbor, we're passing it the arguments -c5, and rather than node.host, we're sending it event.element. The event.element field or property will actually be storing the IP address of the device next to the one that we're looking for that's reporting the outage. So we're going to see if that device is responding as well. Going back up to some of our rules here. Here's a good one for us to look at. This is a more complex way of executing scripts inside opEvents. Rather than calling and executing them all at one time, as we did here in Rule 110, in Rule 100, what we're saying is, if the event contains the phrase node down, then call an escalation command. Now, escalations are included in the event actions file at the very bottom of the file. Escalations start a timeline during which the event actions and opEvents can do things at specific times following the moment of the event. Now, the escalation, the timing of this escalation timeline starts at the moment the event occurs and then can go on for as long as you want it to. Essentially, it can run forever until the event is either acknowledged or the event auto closes itself. So let's go down and look at the node down escalation. Again, escalations are included at the very bottom of the file. All right, so we have several escalation commands. We have one called weekday. So for example, we might have different emailing or text messaging or help desk requirements Monday through Friday, 9 to 7. Then we do after hours, so 7 to 9 a.m. versus what happens on weekends or holidays. Here we have a general troubleshooting escalation, and then we have the node down escalation. The node down escalation allows you to define, or any escalation allows you to define a minimum or window of priority, the days of the week that this escalation will be applicable for, the times of the day. And then again, starting at time 0, which is the moment the event occurs, 90 seconds after the event occurs and gets reported, this escalation policy will run a script called validate node down, which in this example calls an external file, which runs several commands at once, and then returns whether that end device is actually up or down or not. 120 seconds after the event occurs, it'll run a script MTR node. And then at time 180 and time 360, it'll continue to run this validate node down command. So the concept here is very simple. You could go ahead and create a series of troubleshooting commands that run, and the longer that the event occurs or the longer that the event is active, those can continue to run, and when they hit a 24-hour period, the timer will reset itself and they'll continue to run again. So you may say, for example, at time 0, do nothing, but if the event is still active after 90 seconds, I want to run some troubleshooting commands. And if it's still active after 10 minutes, I want to go ahead and text the on-call technician. If it's still happening after 30 minutes, I may want to email the CTO of the business. If it's still a problem after 4 hours, I may want to escalate this to the CEO or to a manager, or send a flash message to the entire engineering team and increase the priority. So there's a lot of things that you can do inside the event actions system, inside opEvents, in order to help not only troubleshoot problems, but again, remediate and fix issues. For example, you may have a situation where an event's occurred. It's telling you that the power over ether service on a switch is down. And so what you could do is you could call an external script, which connects via SSH to that box, executes the CLI command to restart the service, and then retest that after 5 minutes to make sure the service is still up. So again, event escalation rules are covered under the EventActions.nmis file. These will include policy scripts and escalation requirements. Scripts can call anything internal or external to your system. Essentially, anything that can be executed from a Linux command line can be executed from the event actions script section. So that could be a Linux command, a bash script, a Perl script, PHP, Ruby on Rails, Python. Those scripts can, of course, use different types of APIs and programming idioms and opportunities to reach out to third-party systems and push information to BI systems or data lakes, or pull information from databases, push information through APIs, etc. So this has just been a quick walkthrough of what the event action scripting system can do for you and how you would set it up. If you have questions, please contact Leslie Lawyer at usa@opmantic.com. If you have specific technical questions and you'd like a little bit of help or a demonstration or walkthrough, please feel free to email me directly. That's Mark Henry at markh@opmantic.com. Thank you very much for your time, and I look forward to talking to you soon.